and welcome. My name is Dan Oak and I'm a student at Athabasca University, currently taking the course Computer Science 308 Java for Programmers. And today I'm going to do a walk and talk through of tutor marked exercise 1. So let's get started. So tutor marked exercise 1 has 4 programs associated with it. Program 1, you have to create a circle class with 2 constructors and all of these methods. Program 2, you have to create a full name class, a mailing address class, a shipping label class, and a test program for all 3. And then programs 3 and 4 are about completing exercises, programs, within the Thinking in Java textbook. The Thinking in Java textbook is the textbook associated with this class, and it is free, available online as well. So, for the circle class, we'll just look at it in a little more detail here. We need to write a class called circle, which has 2 constructors. The first constructor is a default constructor, i.e. it takes no parameters, and it supplies default values for the coordinates and the radius. The second constructor takes 3 doubles as parameters, corresponding to the x and y coordinates and the radius. And the following methods must be included. We need a circumference method, takes no arguments, returns a double, and it simply returns the circumference of the circle. An area method, again, takes no arguments and returns a double representing the area of a circle. A set radius method. The set radius method has a single formal parameter of type double, so it takes in a single argument as a double corresponding to the radius, and it will set the radius accordingly. So like all set methods, it is void return type, and this method is going to be called by the constructor and checks the radius against a maximum value. So if the radius is greater than the maximum, the set radius resets it to the maximum, and again, we're setting the maximum, and it resets it to the maximum using a ternary conditional operator, and we can set our own maximum value. And then we have a print attributes method, takes no arguments and is void, and it's just going to print the coordinates, the radius, the circumference, and the area of the circle. We have this isInside method, which has 2 formal parameters of type double, so it takes in 2 arguments of type double representing the x and y coordinates, which are a point, so it's going to represent, you're passing in essentially a point, the x and y coordinates correspond to a point, and it's going to return a boolean, which is going to indicate whether or not that point is or is not inside the circle. So it will turn true if the point represented by the parameters passed in falls inside the circle or on the circumference of the circle, and false otherwise. We also have a move method, which has 2, it's going to take in 2 arguments of type int, representing a point again, x and y coordinates, and it's just going to move the circle, which is, again, has an x and y coordinate associated with it, representing the center of a circle. It's going to move that circle by the amount specified. So let's look at that. So this is, I'm using the IntelliJ IDE for all my classes, and as you can see here in the project folder, I've got a project AU COMP308 tutor marked exercise 1, and it's got the classes we just went over. So circle, full name, mailing address, shipping address, and the exercise test classes. So the circle class, I'm just going to kind of read through it. I try not to be too slow about this, so I'll try to just kind of talk about the highlights. You will note, though, for a lot of my code, I've included java.comments. So java.comments, for anyone not familiar, are multi-line comments, but that are a little extra in that they can be run through a program that will create and automatically generate professional-looking HTML files for you. Among other things, you could create PDFs or whatever you like that are just really nice professional documentation for your code. That's the advantage of using a java.comment. So you could use a regular multi-line comment by taking away this asterisk, and now by starting with a / asterisk and ending with a asterisk / anything you put in between here is ignored by the compiler and is considered a multi-line comment, as opposed to, using the double / to create an inline comment, which only comments everything out until the end of the line. This is a multi-line comment. When you add the extra asterisks, you have a java.comment. and you can see the color change here. And this means that it can be run through that Javadoc program and generate that beautiful HTML code. And that's why I have these like @author Dan Oak and @version 1.0. Those tags are associated with Javadoc, and they are used by the Javadoc program to create certain things. Especially down here, you've got the @param, @return tags. They're used by the compiler. So with the circle class, you can see here, public class circle, I've got 4 instance variables, so 3 of type double, well, all of them are of type double, so, and they're all private, which again is what you want to do most of the time when you create classes. You want your data members, your fields, your instance variables to be private, and then you'll make public methods in order to access those. So instead of accessing the fields directly, typically you'll make them private, and you'll create getters and setters, or accessors and mutators, depending on the verbiage you want to use. So we've got our 2 private instance variables of type double, x and y, which correspond to the x coordinate of the circle center and the y coordinate of the circle center. And we've got the radius instance variable of type double, which is the radius of the circle. We've also got this max radius here set to 100. And this is basically what we are saying. We want the maximum allowable radius of a circle to be 100. We've decided this. Now, it's got this extra access modifier. We've know a couple of things here. So it's private like all the other ones, and it's of type double, but we've also got this private static. So the static indicates that it's associated with the class and not an instance of the class. So these are instance variables, the x, y, and radius coordinate, meaning every circle that you instantiate from this class will have an x coordinate, a y coordinate, and a radius, their own values. Having the keyword static here means that the maximum radius is not owned by an instance of the class. It is owned by the class. It is associated with the class itself, not any particular instance. So every circle that you create will have access to this, but they won't have their own. They won't have their own maximum radius. They will have their own radius, but the maximum radius that a circle can be will be 100 for every circle. That's what the static keyword indicates. And final, the final keyword just means that this is actually not an instance variable like I've been referring to it, but it's actually a constant. Final is just means constant. Anyone familiar with C++ would know that if you put the keyword const, that indicates a constant in C++. So if you've done any programming in C++, that is a constant value. So it just means that it can't change. A programmer can't change the maximum value down here. We've got a default constructor as per the specifications. Remember, we need to have a default constructor that takes no arguments, and then a second constructor that takes in the 3 parameters of type double. So the default constructor initializes the circle at 0, 0 with a default value, default radius of 1. So it's a unit circle. And set at 0, 0 is somewhat useless because on an XY coordinate system, 0, 0 is the top left. So if the center of circle is at 0, 0, we're only going to see half of a quarter of the circle. It's like a picture you would create in grade school with the sun, just a quarter of the circle here. But that's fine. And I'm using this notation. You'll notice instead of setting directly, I could have just done this. I could have just went x equals 0, assign 0 to the x coordinate, y equals 0, assign 0 to the y coordinate, and radius equals 1.0. I could have done that, and that would have the same effect as what I'm doing here. However, I chose to do it this way simply for the fact of this is a common convention. If you have overloaded constructors in your class, meaning you have more than one constructor, which I do. I have a default constructor, no args constructor, and a parameters constructor that takes 3 doubles. It's often convention that your constructors that take less arguments just make a call to your constructor that has the most arguments. In this case, my 3 argument constructor, by using this keyword. If you use this keyword, but not this dot notation like we used, I just used to show you, or down here you can see this dot. The dot notation here is a way to access methods or fields of a class, i.e. right now I'm trying to access the x variable associated with this class. So I'm going this dot x. Or if I wanted to access a method, I could go this dot and the method call. When you use this and then in parenthesis here, this is counting as a constructor. You're accessing a constructor within the same class. So I'm saying, hey, use one of the other constructors in my class. Which one? Well, the one that takes in 3 instance variables, or 3 parameters of type double here. So that's what this is. This is simply calling the another parameterized constructor within this class, one that takes in 3 values. And that's this constructor right here. So parameterized constructor initializes the circle with the given x, y, and radius values, and I've got these @param tags, x corresponding to x, y, and r, the x coordinate of the center, the y coordinate of the center, and the radius of the circle. So the parameterized constructor takes in these 3 parameters of type double, and for the first 2, x and y, it just assigns the parameter to the identically named instance variable. So parameter's identifier name is x, I assign it to this dot x, and that's indicating that I want to assign it to the instance variable x, and I'm doing the same thing for y. Now there's different schools of thought on this. So the reason I have this weird kind of this dot x equals x notation is because I'd have a naming conflict otherwise, because I've given the parameter name x as its parameter name that I'm passing in, and I want this value to get assigned to x, the instance variable name, the instance variable associated with this circle object. But if I didn't have this, it wouldn't work. You see there's like an error here. I'm getting a squiggly line. It's because there's a naming conflict, and basically it thinks I'm trying to assign x to itself. So and that's a scoping rule thing, because I'm like, if you're familiar with naming conflict scoping rules, because this x only exists within this method. It dies after this curly brace here, so it only exists in here, whereas this x, well, correction, if this dot x, like the instance variable, exists in the class, exists for the object. So a couple ways you can defeat this. Some people like to have just a different parameter name, like in that case x value, and then I can assign x value to x, and there's no naming conflict. You can see this turn pink. It's associated with the private double x associated with the class. That's one way to do it, and then there's no naming conflicts. You just have your parameter names different than your instance variable names. Obviously something that's very similar, like in this x value versus x. Or as you can see, another common convention is just to do the this dot notation. This dot says, hey, this is referring to this object that was created, that this method is in. So this refers to the object. So if I go dot y, I'm accessing this object's y variable, and this y now clearly just represents the y that got passed in. So there's different schools of thought what to use. I personally prefer the this dot notation. It's just a fairly common convention, so that's what I'm going to go with. And then so I'm setting these 2 variables directly. I'm just taking the parameter values and passing them in directly, and assigning them to their instance variables. But for radius, I'm not doing that. I could have done that. I could have went, this dot radius equals r, and passed that in. So passed r in and assigned r to radius, and it would have done the same thing as these 2 variables. I'm just passing the value in directly, but then I have no validation, no checking. So I can pass any value for radius. I could pass a 1,000 in, so I could have a radius of size 1,000, which I know is greater than my max radius, what I wanted to allow. I could pass in a negative value for radius, which doesn't make any sense. You can't have a negative radius, unless we're thinking of black holes imploding on themselves or something. But so it made sense just to directly pass in values for x and y, because I can have negative and positive x and y coordinates depending on where you are on the Cartesian plane. But it doesn't make sense to pass in the r directly. We are going to use a set method, pass in an r to the set method, and let that have some validation. Another reason for doing that is because it told us to do that in the specifications here. So and you'll notice too, I actually am so used to going this dot, but I didn't need to use this dot in this case because radius has a different name than the parameter I used to pass it in. So If I had passed this in as radius, I would need the this dot. But because I'm passing it as r, I could have just went radius directly. There's no naming conflict because the names are different. But let's get back to this. But anyway, instead we're passing r into the set radius method, which this is going to ensure that the radius is within the allowable limit. So let's just go directly to that set radius method for a second. So the set radius method down here, as you can see, it takes in a parameter of type double, returns nothing, and the java.comment comment says here, this validates and sets the radius. If the radius is greater than the max radius, it is reset to max radius. If you give me something bigger than the max radius, I'll give you a circle as big as I'm going to allow, which is 100 in this case. At param r is the new radius. That's just, again, java.comment. The tag is letting me know, we'll let the java.doc program know that, hey, the parameter is r, and write this. So I'm using a ternary operator to validate the radius. So again, that's what we were told to do. It said using a ternary conditional operator. That's how we were going to ensure the radius there. And so if you're not familiar with the ternary conditional operator, it basically follows this format. You have some Boolean conditions, so some condition that's going to evaluate to true or false. In this case, r greater than max radius. That's either going to be true or false, depending on the value of r. And then if it's true, do whatever, you put the question mark here and do whatever follows the question mark. That's what gets returned in this case, so it gets used. If this was true, else, the colon here, is like the else. So if this evaluated false, return r. So it's as simple as that. So basically we're going to come in and we're going to go, if r is greater than max radius, so if I passed in 50, well, this would evaluate to false. Our 50 is not greater than max radius, so we wouldn't do what came after the question mark. Instead, we would return what came after the colon, because this evaluated to false. So we would return 50. So we would just assign 50 to radius, which is what we wanted. We wanted to assign the value we passed into radius. If r was 150, which we know is greater than max radius, which we have set as 100, 150 greater than 100? Yes, it is. It's true. So this would evaluate to true, and we would return what followed the question mark. So max radius would get returned, meaning you put in 150, but I'm returning max radius. So that's how a ternary operator works. I have a little note here. Alternative, I could have just used this dot radius equals math.min. We needed to use a ternary operator because it was specified in the in the tutor mark exercise assignment sheet. But if you didn't want to use a ternary operator, there's a built-in math.min function, a min method associated with the math class that takes in 2 arguments and returns the minimum value, which is essentially what I'm doing here. So I just could have passed in my radius value that got passed in a max radius, and this would accomplish the same thing. And again, this is just like an if-else statement. I could have went if r is greater than max radius and then return max radius, else return this. So back up to the top here. So we have our methods that we're supposed to have. We need, again, remember, we're supposed to have a circumference method, an area method, print attributes method, is inside, and move method. Well, let's work on the circumference and area method first. Circumference method simply return 2 times math.pi times radius. Math.pi is a constant associated with the math class. So I didn't need to import. The math class is kind of included automatically when you in Java, but you do have to, because this is a class constant, you do have to qualify pi with math. So you have to write math as the class. That's why it's capital M dot pi. You could actually import that and just use pi directly, but this is more conventional. So this gives me access to the value 3.14159.265, or whatever pi is. So this just makes it more accurate, because this is accurate to whatever the people in Java decided, and it probably goes on for a lot longer than I can remember the right values of pi. So we're going to return 2 times pi times radius. And why? Well, because that's the formula for circumference of a circle. Formula to calculate circle circumference is 2 pi r. You may remember from grade school. Calculating the area of a circle, we've got math.pi times radius, again, because the formula to calculate the area of a circle is pi r squared. Now we could have also used one of the instead of doing this, we could have done, I'm just going to comment this out so it doesn't, we could have done math.py times, there's a function, math.pow, and look, it's the IDE knows what I was trying to do. You could have done math.pow, which is a function, power, it's the power function, and it takes in two arguments. The first argument is the base. So, for example, it would look like this. If I pass in radius and I passed in a radius of 5, or right, that would be the base. And the second argument that gets passed in is what to raise the base to. So in this case, 2. So 5 raised to the second power, or 5 squared, would be 25. That's what that's doing for me. If the so that's one method we could have used, but instead this has a little more computational power behind it because you are relying on a function, which even though it's simple for us, there's overhead associated with it. Someone put more program behind that, and ultimately somewhere in that program it's probably just doing this. So it's simpler for us just to do it. But there's an argument to be said, whatever you find is more clear. Math.py times math.pow, you know this is a power function, radius squared. Some people like this better. Some people like the this here better. This is definitely less computationally expensive just because you're just timesing. You're just using a simple multiplication operation, timesing radius by itself to get the squared effect. But with computers today, in either way, you're not going to notice any difference. So it's really a matter of personal preference which one you use. So that's the area, circumference, set radius we've already talked about. Print attributes function, again this just prints the circle's attributes, and I've just used it a formatted way, so it takes no arguments, returns nothing. System.out.printf, and again I'm using the printf as opposed to println or printline. This just allows me to have a little formatting that I can do. So the way printf works is you take your first argument is your string literal, so between your quotes, and in your string literal you can just include these little format specifiers, which always start with a %sign and then end with something like F in this case for a float. It could end with a D for, or like various other things, S for string and stuff. And in between here, this 0.2 represents I want a float that's accurate to 2 with 2 decimal places. So this little tag just basically says, hey, give me a float with 2 decimal places, and same with this, and then this is just the next line. So this, the way string format works is it'll just, and then the first argument is a string literal, and the following arguments, a variable number of arguments, whatever you want, that match the number of specifiers accordingly, will get placed in when this gets printed out. So if I'm passing in x and y, x gets put in place of this when this gets printed, and y gets put in place of this. And it'll get printed, so it's expecting a float because of the F here, and it will print it out with 2 decimal place accuracy. And this specifier, next line, just indicates that this is like a print line. It'll print this line, and then this will be on the next line. We could have used \n here, for anyone more familiar. The advantage of using the %n is it's just cross-compatible. It will work on all platforms, or virtually all platforms. So we're going to print out the center circle, then radius, circumference, and area. So again, I'm using the printf for all of them. These ones my arguments are just direct values to get placed in. X and Y and radius will get put place of this. Here I'm calling the circumference method, which we just went over above. Right there. So here I'm just calling the circumference method, which we know returns a double, which now will get placed in here. And a double can get placed in a float because they're both floating point numbers. Area will get put here. The print attribute function there. And why we're doing a print attribute and not overriding a toString, because I could have just overridden the toString method. So I could have just done this, In fact, I could do it the old-fashioned way. I could do public string, toString, override that, put in some stuff, and then just basically copied all this here and put it in here and overridden the toString method. I could have done that. I could put this little @ override annotation. This is not necessary. but this just tells the compiler I'm trying to override the toString. So if I made a mistake in the signature block, let me know, and so that I'm actually overriding it. I could do that and put this all in here, and then just when I go to print, I could do a sys out. So when I go to system.print and I could just print my circle. Say if I had created a circle, circle 1. This is giving me errors because I don't have any of these things. But if I printed my circle 1, it would print all this stuff up. I could have done that, but for the specifications of this project, say to create a print attributes function. So that's what we've done. Also, if I wanted to make a toString, I wouldn't have to do that long way of doing it. I could just go up to code, generate toString, and I want a toString with these values, and the toString method gets generated for me by the ID. So again, as you can see, it's got the @override tag, public string, toString, takes no arguments, returns a string, and it's just going to return. It's a little different format than I have here. It's going to return a string within curly braces, x equals this, y equals this, radius equals this. I don't get my other stuff, but again, I could just copy and paste this into here and do that. We might do that after. Basically what I would do is I would, instead of returning right away, actually return, I'm just going to return an empty string right now, a placeholder. There's a function called, there's a string.format. String.format, am I getting that correct? So string.format kind of works like this. It takes in an argument of a string literal as its first argument, and then parameters that are going to replace this. The difference is this prints out right away. If I go system.printf, that just prints right away. If I do string.format, it returns a string, so I can return it to string format like I've done here. I've created a local variable string, a local variable type string called formatted string, and I can assign that, and then I can just keep updating formatted string accordingly. So I can go formatted string plus equals, I think I just screwed up that whole thing, so let me just undo that. What am I doing here? Formatted string plus equals radius actually, you know what? This would be done better with a string builder. More or less, I could keep doing this. I could make this formatted string. I just don't want to make this too long, but I'm going to do this in the next line. There could be a better way to do this with a string builder. I'm just going to make this original thing longer. Copy. This is not going to look pretty, but I'm just going to do to show you get the exact same thing. And then radius. So what I'm doing here is I've just created a longer string literal from the start. IntelliJ knows what I want. I've created a longer string literal from the start that still has the next line, so this still will print the same way, but I've just, all my format specifiers are on this one string literal. But again, I can have any number of arguments follow the string literal, so these will still all just replace the corresponding string literals or format specifiers in the correct order. So this will create this string format function will create a string, which I'm assigning to format a string, this local variable, and then I can return that, and that would accomplish the same thing as this. However, this toString method wasn't meant to be done. It wasn't included in the specifications. This print attributes was. So I could theoretically leave it open. It doesn't matter. It's just there doing the same thing. But that was a long tangent. I apologize. I don't think I'm going to do too many more videos. I just realized this video is already quite long. I'm not very good at this, and I'm not even through the circle class. So I've got another method called isInside. It takes in two formal parameters of type double, x and y, and returns a boolean. You can read the java.comments. Basically, it's following the Euclidean. I'm using the Euclidean distance formula to accomplish what I need to accomplish here, and that's basically you take the difference between 2 points, two x coordinates. You take the difference, square it. You do the same thing for the y coordinates. Take the difference, square it, and then you add these together and take the square root. So that's the Euclidean distance formula. And that's essentially what this line of code, it's exactly what this line of code is accomplishing. So we create a local variable of type double distance equals math.sqrt. This is the math.square root function, just like the math.pow and stuff I showed you earlier. So the square root function is going to be applied to everything inside these parentheses. So all this happens first, and then we take the square root of that. So we're relying on the math.pow function to, first we're getting the difference between x, the value that got passed in, and this dot x. So the x associated with this object. The order doesn't matter. I could have had this dot x minus x, because when you take a difference, depending on this order, you're going to get a positive or negative value. But because we're immediately squaring it, it doesn't matter if it was positive or negative. Negative 2 squared is 4. Positive 2 squared is 4, right? No matter what, we're going to end up with a positive value based on that same absolute distance. So do math.pow, passing the first arguments, the distance between the x coordinate, the x value we passed in, and the x coordinate of this circle, and then we're squaring that. We're going to do the same thing for the y coordinate, and then add them together, and then take the square root. So this line of code is accomplishing the Euclidean distance formula. And then I'm simply returning a boolean. I'm saying return distance less than or equal to radius. So if the distance is less than or equal to radius, i.e. it's in the circle, the point represented by the x and y coordinate that got passed in, if that distance, after we did this formula, if that distance is less than or equal to the radius, well, that means that the point is in the circle. So this is going to be true, and we're returning true. Otherwise, it's going to be false. And the comment tells you that. If the distance is less than or equal to radius, then the point is within the circle, and true is returned. And the last method, so again, we've went through circumference, area, set radius, print attributes, isInside. The last method is move. And this method just moves the circle by a specified amount. It takes in the two arguments, dx and dy. That just stands for delta x and delta y. So delta is the little triangle symbol, just means difference of. If you're familiar with if you remember in your math and your physics and science and all that. And so we simply go this dot x, referring to the instance variable associated with this object, and we're going to increment it by the amount that got passed in. So this dot x plus equals dx. So I'm using the compound operator just to increment the x variable associated with the circle by the x value that got passed in. And similarly doing the same thing for y. So increment the circle's x and y coordinates by the amount of the parameters that got passed in. And that's the circle class. I meant to explain that a lot quicker, but that was quite slow and painful. I apologize. The test class, I'll try to be a lot quicker here, just tests the circle class. So this is circle test, and it simply just calls the main method right away, public void main string args, and does all this stuff inside there. So I'm just testing a bunch of things. So this tests the default constructor, then I'm testing the parameterized constructor, test the circumference calculation, test the area calculation, test the maximum radius enforcement, test isInside, is the point inside, and I have to do that a few times because I'm testing if the point's inside. I'm doing the edge case, so testing if the point is on the circumference, so literally the edge case, and testing isInside when the point is outside, and then I move the circle. So this is kind of just a simple test case. It may, I think it's covers everything that I need to. To make real proper test cases, you have to be really exhaustive and think of all the different things. Create the default constructor, the parameterized constructor, pass in invalid and valid arguments, and do all kinds of stuff. We were just meant to create a simple test class for this, I believe. I'm not even sure if I had to be honest. So you don't even have to create a test class for this. So I just did because, well, you should test your programs. But again, each one of the test things, it simply prints out a statement using system.out.println. It simply prints out what you're testing, so testing default constructor, testing parameterized constructor. Then we're creating the appropriate object. So in this case, I'm creating a default circle by passing no arguments in. When I go circle C1 equals new circle, no arguments passed in. And then I'm just calling the print attributes method. So that's pretty much what I'm doing for a lot of them. Printing something out saying what I'm doing as the first line. And at the end, I'm using the print attributes method to print something out. My comment says what I'm expecting. Here I'm using the parameterized constructor by passing in 3 arguments, printing the attributes. Here I'm just using this printf so I can use my formatted print stuff. And I'm just printing out testing the circumference calculation. With these ones, I'm doing something a little different. I'm doing a printf, and I'm like, hey, I'm expected to get this. And the first argument that replaces this is what I'm expecting. I'm just doing it directly. 2 times math times pi times 5, because that's how you'd calculate the circumference. 2 pi r. Well, 2 times pi times r, 5 in this case. I'm just saying this is what I'm expecting, and I'm just doing the math out longhand by using the computer here, but without using my circumference calculation. And then the second argument is like I got this. C2.circumference, I call it circumference. They should be the same thing because their circumference under the hood is just doing this, right? It's just this 5 would have been the radius, which is what it is. So that's what I'm doing. That's kind of how the circumference calculation is happening. Same thing for area. Again, I just do it out just using mat.pi times 5 times 5, knowing that the radius is 5. And the area function is just doing this behind the scenes. I tried to create a circle by passing in a radius of 150 just to verify that the maximum enforcement comes into place. So I'm expecting radius to be 100 via that ternary operator. And then this is a point that's inside the circle. This is a point that's on the edge of the circle. And you could do this with scrap paper and verify that this is true. And then this is a point that's outside the circle. I just want this to be true, true, false. So without further ado, let's run this. So yeah, testing default constructor. You can verify these numbers afterwards, but this one's fairly easy. It should be, if it's got a radius of 1, the circumference is going to be 6.28. If you're remembering your, again, high school trig and stuff, that's pretty, that should be obvious to you. If you've freshly done that. If not, it won't be obvious. It wasn't obvious to me. Area equals 3.14. So again, well, if you have pi r squared, pi is 3.14 times r, 1 squared. Well, 1 squared is 1. This makes sense that this would be the area. But you could go through a calculator and verify that this is correct. But yeah, this is essentially what the test program's trying out. And you can see for inside the circle, I had true, true, and then false. And that makes sense because these both were inside the circle. This was actually inside the circle. This one was, the point I gave this one was on the edge of the circle. And this is false. You could run these programs as well with directly in the command prompt. I did that earlier, but every time I ran it, the processing power between having the IDE open, the command prompt, and everything shut off the recording. So I'm not going to do that this time. Yeah, so we satisfied everything in Program 1. It was a long video just to get through Program 1. But I think we'll end it there because of the fact that, well, it's just been too long. And yeah, I'll show you. So for each of the programs, I'll just move on for a second. I like the colors. I like to kind of keep track of what I'm doing. I basically had previous code versions just kind of indicating what I'm doing. I pointed some things out, like when there's something special that I'm doing, like printf instead of just using the regular print line. At one point, I was going to have the set radius method throw if the radius was less than 0, because it doesn't make sense to have a non, like either a 0 radius. 0 radius is fine, just means there's no circle, but a negative radius is impossible. So I did originally at one point have, if you tried to put in a 0 radius, throw in a legal argument exception. I took that out because I just didn't know if they wanted us to do that stuff, because I was trying to follow the specifications exactly, and it didn't say to do that. So but I might put that back in, because it really, if someone puts in a radius that is less than 0, I don't want that to happen. I don't necessarily care to deal with it, like with a try catch and let them and re-prompt them. I could do that and be nice, but at very least I should throw something, legal argument exception, and just say, do that. Yeah, doing all that. Oh, I did have, at one point I was getting input from the user, so I just created a scanner. I obviously imported java.util.asterisk or .scanner class, probably just is better. I created a scanner. I used a while true loop just to prompt the user for a radius or let them quit when whatever they input. I parsed it to a double, and if they didn't input the right thing, I reprompted them. That was just when I was getting it, and then I realized that had nothing to do with the specification of the assignment, so I gave that up. This is the things that my circle test program is doing. I need to test both constructors, validate the circumference and area calculations, ensure that I can't exceed the max radius. This was my testing table of what I was testing, the input I was going to give, and what my expected output was. This was the test program. Again, it might be a little different here than it was when I printed it. Basically, this just verified the point on the circumference. That's an edge case. So again, this is what I wanted to do. And this is one of the tests. It verifies that points inside and outside the circle return the correct Boolean values. It also verifies that a point on the circumference, that's an edge case, pun intended, returns true. There you go. And again, as you can see, I do have the other codes done for program 2. This is for full name, mailing address, shipping address. I'm using annotations, so I have some notes on Java 5 unit, JUnit annotations, and I have some notes on that. Programs 3 and 4 code versions and notes. These are just the notes of what the exercises are doing, where they're associated in the book. I end up doing an extra exercise because the book associated with Vital Source. So when you go to the website, we have access to the Vital Source textbook. The page numbers don't match up as exactly with a PDF version of the website that I downloaded myself. So they don't match up at all. And so I ended up doing the first exercise correctly, cycle class, and then I ended up doing this exercise, but this wasn't the one I was supposed to do. So that's why I have this labeled as 2 exercises for 2 marks exercise 1. We'll include this and this. And I did them. I still did them. And I still included it in the package that I'm going to send in because I did the work. Might as well do it. But this is the real exercise 4. So this exercise 4 on error propagation never should have been done. So I did all that work for nothing. But, good coding practice. This is the real exercise 4 that I should have done, which is basically dealing with interfaces and stuff. Anyway, these are the little notes I include to help myself with the tutor-marked exercises as I go. But like I said, this video is quite long. I'm not very good at doing this, so I'm just going to call it quits. Show you the other programs are done. Like this is kind of just quickly. This is the full name class. This is the mailing address class. This is the mailing address test. So this is where I'm using the JUnit stuff, which just basically uses these annotation tags at before each. This runs every time before a test. These at test tags just let the JUnit program know that, hey, this is a test thing. And this is just me testing all the stuff. You could do this without JUnit and without this test, just creating your own print functions and test functions, which I've done lots in the past. using system print. This is just like an extra tool to use. Shipping label class, and so the shipping label class basically encompasses the full name class, the mailing address, and the shipping, and then it just prints out, like, you know, some stuff. Hey, ship from this person to this person. What else? Modified music. So this is a modified music class. Basically, this was one of the assignments. We just had to create a playable interface with you know, one of the abstract methods as play. Assign it to, you know, implemented in other classes. Class wind. So there was a main instrument interface as well. There's a lot of stuff happening. I don't want to make this video. I kind of wanted to go through all this stuff, but the video is too long. So the exercise class. So this is the exercises I did. One of them was you basically had to create a cycle. I'm just really quickly just talking about it. You had to create a cycle-based class. I think at one point I had this as an abstract class, because you never really need to create a cycle. It is an abstract class in a sense. But obviously I don't have it in this iteration as an abstract class. Doesn't really matter. But it's a cycle. It's got a wheels method and a ride method. The ride method simply calls the wheels method. And the whole point is, in my derived classes of the cycle class, like I have a few derived classes: class unicycle, extend cycle, class bicycle extend cycle, and class tricycle extend cycle. I override the wheels method in each of those classes. So I don't override the ride method. I just inherit that directly. But I override the wheels method each time, outputting the correct number of wheels for the the class. Like unicycle returns 1 wheel. Bicycle returns 2 wheels, and tricycle likewise returns 3 wheels. I use the add override annotation just to let the compiler know I'm actually trying to override something. But the whole point of doing that is to learn polymorphism. So you're creating this class hierarchy with a base class and derived classes that override a method, and then in the test program, I just create a cycle array which has a unicycle, a bicycle, and tricycle as its elements. I use a for each loop to iterate through the array, pulling out a cycle object at a time. I call the ride method on it, and again, this calls the ride method, which, as we know, I never overwrote in the other classes. The ride method is just associated with the cycle class, but because it calls the wheels method, which got overridden in every derived class, when we call the ride method, this should output the correct number of wheels associated with whatever the actual element was. So you can read this java.com, and it basically says, this is testing exercise 3, cycle, hierarchy, and polymorphism. I was going to say monarchy for some reason. Demonstrating cycle, hierarchy, and polymorphism by creating an array of cycles and calling the ride method that is inherited from the cycle class on each subclass of the cycle class. Since the ride method defined in the cycle class and inherited by the subclasses calls the wheels method defined in the cycle class and overridden by the subclasses, the ride method is polymorphic. That's a mouthful, but that's essentially what's happening there. This class here, I have this all in the same file just because for simplicity, really. This is my thing that I shouldn't have done. Had nothing to do with what I was supposed to do, but I misread page numbers between my downloaded PDF version and the vital source, and basically you had to create a custom exception just by extending the exception class. So I created 2 custom exceptions: first exception, second exception. Both of them just basically had a parameterized constructor that passed the string that got passed to them to the exception class to deal with it, so making it called a superclass constructor. And I had to create a couple methods: a G method, which throws first exception, just throws first exception, and an F method, which throws second exception. And what the F method did is, as you can see here, it within a try-catch clause, because I know this G throws an exception, I call the G method, and it demonstrates method chaining. Method chaining because F calls G, which throws first exception. Because remember, the G method throws first exception. Then I catch first exception, all still within the F method, and then I throw a new second exception. So second exception thrown in F after catching the exception. And that just basically demonstrates method chaining. Again, it's in my exercise test class in the main method here. After I do the cycle stuff, I do the exception stuff just to verify it all works. And then, but this was the real thing I was supposed to do, was the modified music, and I did that. But anyway, this video has been long, and it was not my intent. So I apologize, but if you're still watching, hopefully you learned something. And yeah, there you go. So follow me for more videos on tutor marked exercises. Although this probably will be the last, because I am no good at it.